Hello and welcome to part 5 of this course on temperature measurement using sensors. So in this session we will understand about fundamentals of thermography. Here we will talk about the non-contact method of thermography. We use various types of sensors for automation and maintenance in production plants, construction and maintenance of bridge and building, biomedical and healthcare instruments, etc. This part of course will give you an insight of passive electrical sensor called thermography. First, let's try to understand the background of thermography. All temperature measurements need physical contact between the thermometer system and the body or the equipment under test. Now consider the following situations. The temperature of the body under test is above 1400 degrees centigrades, or the body is not reachable for temperature measurement, or the size of the body is too big. In such cases, the temperature measurement is done through radiant energy emitted by the body when it is hot. This radiation is electromagnetic in nature. All hot bodies emit visible radiation between zero point 0.3 microns to 0.72 microns and infrared or thermal radiation between 0.72 microns to 1000 microns. The emitted energy varies with wavelength and temperature of hot body. The range of wavelength for equipment having temperature above 250 degrees centigrades lies between 0.72 microns to 10 microns. Therefore, this radiation is focused onto a detector. This detector acts like a black body so as to absorb entire thermal radiation incident on it. The increase in temperature of the detector will be a measure of the temperature of hot body. Thermo means heat or temperature and graphy means image. So, thermography is analysis of thermal profile in the form of an image. A thermal imaging camera is able to capture thermal profile of an object for analyzing the probable faults. With the help of this diagram, you will understand how thermal imaging camera works. So here we can see that an object when it is hot is radiating IR radiations in the atmosphere. These radiations are captured by the thermal imaging camera, which converts the entire image into a thermal profile of the object. Now from the different colors of this object, we can identify the faulty area. Now let's consider an example to understand the thermal profile. This example shows an overhead transmission line. The visual and thermal image is being compared here. As you can see, the middle line is red in color. This means that overheating is happening here. Now, the reason for overheating could be loose connection or overloading or aging of material. Consider another example. This is a visual and thermal image of the pipes in the network. The red area in thermal image shows imperfect insulation. It is important to understand that the object's temperature cannot be calculated by just measuring its emitted infrared radiation. It is important to gain knowledge about the emissivity of the object. An object with high emissivity will appear hotter as compared to an object with low emissivity when placed together under same conditions of temperature, moisture, and other environmental conditions. The object with low emissivity will appear dull to thermal imaging camera in the same way as it appears to an human eye. Another example shows that the problem is in the middle ring, which is appearing red in color. Elsewhere are the reflections. For proper analysis of thermal profile, it is required to overcome the problem of emissivity, so any one of the following methods can be adopted. The first one says, provide a suitable numerical value for temperature compensation to thermal imaging cameras, which depends on the study of emissivity of the object under consideration. This value is utilized by the signal processor of the thermal imager to correct the temperature measurement value. Another method is to paint the surface of low emissivity object with a high and constant emissivity coating. But this is not a feasible method on all manufacturing plants or buildings if the object is placed at inaccessible region. An alternative to this method is to make a comparison of thermal profile patterns between objects of similar emissivity operating under similar conditions. This way, we measure the temperature of each individual object, thereby identifying the faulty object in an equipment or manufacturing plant. Hence, timely maintenance job can be done before the equipment fails to operate and causes more damage. Thermography is gaining importance for conducting predictive maintenance in places like manufacturing plants and malls because of the following reasons. While commissioning of new equipment, thermography helps to identify probable defects at the most primitive level. So, corrective action can be taken before the electrical equipment like electrical motor and circuit breakers are put into operation. In case when electrical equipment demonstrates poor performance or is suspected of operating under faulty conditions, thermography helps to collect operational information so that corrective action is taken before the equipment fails to operate. So keeping this thing in mind, we have three types of maintenance. Reactive maintenance, repair the equipment when it fails. Preventive maintenance is done at regular intervals. In predictive maintenance, problem is detected before failure because maintenance is planned ahead. Other application area of thermography includes solar panel, buildings, agriculture. So let us now summarize our learning. The benefits of thermography are precise and instant thermal profile of an electrical equipment is captured during fault detection using thermography. Thermography is capable of providing thermal profile of moving objects in real time and in low light situations also. With thermography, analysis can be done for the equipment placed at unreachable or unsafe areas, air leakage, asymmetrical heat dispersion, and distinguishing possible irregularities in insulation is also possible with thermography. The technology also has a few limitations: high initial investment, but fast response time of thermal imaging camera and savings done due to early warnings for predictive maintenance must also be taken into account. Mediums like glass act as non-transparent for infrared radiations, so it is not possible to measure temperature of covered electrical equipment. The technology of thermal imaging analyzes the electrical equipment's surface thermal profile. Therefore, it requires expertise and good knowledge to do the analysis of the results obtained during predictive maintenance schedule. I hope by now you have understood basic concepts of sensors and transducers, especially temperature measurement using sensors. You can mail your queries at the given mail ID. Thank you and take good care of yourself.